Okay, we have three dipoles connected, or three dipole system in which they're side by side. They each have the same magnitude and the spacings are identical. And in which arrangement is the potential energy greater? So our potential energy for two charges is Q1, Q2 over R. A dipole system, though, is a dipole is a charge times a distance or a displacement. So, and where we usually have two oppositely charged species at either end. So this is kind of our simple dipole. And so it's actually a vector quantity. Okay, so then the electric field due to two interacting dipoles, or the potential energy due to two interacting dipoles, is a little bit more complex, where we have our R vector goes, or our displacement or distance R goes between the two dipoles. And it's just mu1 dot mu2, and then some other factors that account for some other. Now, if our dipoles are side by side, then they are perpendicular to their R, and so then this term will go to 0. And so we just need to consider, and if they're perpendicular as well, then this term will just be 1 over 4 pi epsilon naught R cubed, mu1, mu2, cosine of theta, where theta is the angle between them. And recall that that if they're lined up, theta will be 0, so cos theta is 1, and if they're anti-aligned, then theta is 180, and then cos theta is minus 1. So then, so for A, we have an arrangement like this, where each of these R's is the same, and then that's 2R. So our potential energy between the first two would be minus mu1, mu2 over 4 pi E naught R. R13 would be mu1, mu2 over 4 pi epsilon naught times, so that would be R cubed, so 2R cubed. And our and U23 would be minus mu1, mu2 over 4 pi epsilon naught R cubed. So our total would be, there's two of these negatives, and then this positive value. Now if we look at the B configuration, where again that we have RR and 2R, U12 would be mu1, mu2 over 4 pi epsilon naught R cubed, U13 and U23 would be similar to U12. And so then our total would be completely positive. And in fact would be pretty much the same, except positive instead of negative for the first term. And so as this one's completely positive and A has a negative term, I would have to say that B is the greater energy. So B configuration is greater than the A configuration. So looking at our solution here, P equals theta. Okay, so they computed it from the electric fields in each case, but that's okay. In the end, we get that that the second configuration is greater. So that looks good.